Hi, it's John, and today I'm here to talk to you a little bit more about working with CNCs, in particular my OMNICNC. It's a 1325 if you weren't familiar already from watching any of the other videos that I have. It's a nice 4-foot by 8-foot CNC with a vacuum table and a water-cooled spindle. It's pretty powerful, the spindle is, and that's nice because I get to work on a lot of different materials as a result. We're going to kind of cover a flotsam and jetsam of things today, because there's a lot of things that, they're only a little 2 or 3 minute topic. You may not know how to do, and so what I'm going to try and do is give you a broad coverage of very small things that you can do to help you fix things in your CNC, fix things in vector to spire if you're using that, perhaps fix vectors and stuff and places to go get nice projects to work on and that sort of thing. So one of the first things I wanted to talk about, I'm going to set my camera back down here because that's the control for the camera, or this camera is the control for that camera. The work out there, some of these CAD source machine websites, I don't know how to talk, have some really cool little projects on it. And my granddaughter was just born yesterday. And so in an effort to get ahead of the power curve, I made her a nice little cradle, whatever you want to call. And it didn't take very long at all. It requires a little bit of sanding and some painting, but Amanda Chung from OMNICNC sent me a link to the website. And so hopefully I can share a little bit of that with you, and you can go out and get some of those files and make some stuff yourself. Something else I found on another website was one of these little maker stools that's used for sitting around in your shop whenever you're working on something or whatever. The really nice thing about this is that they fold up. The crib will also fold up if you wanted to into a nice flat container so that you can carry this very easily around. Now, I'm going to go ahead and turn the camera down, so forgive me while I go off screen. And I'm going to move that down a little bit so that you can see what it is I'm doing. And this is not rocket science, but it is kind of nice because they fold and fit together. Okay, and then provide that it's got a little brace, and the top of the seat has 2 little marks in it. They're little V-bit marks, and so you can drive screws in if you'd like to make it a more permanent attachment. And all you have to do is drop the top on there like this, and boom, you got a nice little stool that works. Until I put the screws in there, it's not going to be real firm. But I was able to get 4 of these stools off of a $34 piece of plywood. And this, I was able to get the entire thing off of a piece of plywood. So you can get quite a bit of pretty useful stuff. Let's say that you got a last-minute family get-together outside and you need some more chairs. Boom, turn the CNC on, 30 minutes later, here's all the chairs. Why go rent? Why go buy when you can make? And that's, of course, what this chair says on the side, if you can see it, and that is the logo for the maker movement, and that happens to be one of the sites where I got this from. So that's going to kind of be the theme today, is making your own stuff whenever you can't find it, or you can't find exactly what you want. You want yours to be a little custom, whatever. That's the nice thing about your CNC is you're pretty much limited only by your imagination. Without going into any greater depth and boring you with my ugly face, I'm going to go ahead and prepare for us to adjourn to the computer, and we'll talk about some stuff you can do in there. Till that point in time, take care. Inevitably, whenever you start talking about techniques for working on the CNC, you have to start with the software, and even if that means the controls on the software itself. What I wanted to talk about here was the importance of getting the order of your cuts correct so that you didn't accidentally cut a piece of material free before you'd perform the less stressful, if you want to refer to it that way, cuts done on the material. So let me give you an example here. I'm just faking a Buffalo Bills plaque for a friend of mine. I'm not selling these or anything, so please don't call the NFL. And what you will see here is that basically this is, if we go over to the 3D view, this is what it looks like when it's all done, okay? Now, these are 60-degree V-carves so that you can get the text out nice and clearly. And then there is the buffalo. And there's pockets, big, huge pockets that are cut with 1/4 inch or about 6.35 millimeters, if that's where you lean from, router bits. Now, you know, despite the fact that the router bit could be moving as much as 20,000 RPM, and be razor sharp, there's still twist and torque that is applied to the material, okay? And so what that twist and torque can do, even if you have the material has tabs in it to attach to the main body of material, it can still pull it loose. So if that happens, then you lose your X, Y, and Z datums, and that can be a big problem because if you didn't mark your material, then you'll find that you are going to have a very difficult time recovering what could be a very expensive material. So first, let's talk about the easiest and most obvious way to fix that, okay? So as normal, we've got a square here. So what we could do is just put a mark right there. And let's just go ahead and copy that. And let's drag it right up here. Okay. And because this is the newest fire, it should do something over there, but it's not going to snap to grid. So that's okay. I'm going to put it right there. Okay. So now whenever I start, what I'm going to do is come over here to the V-carve, and I'm going to say, I want you to just cut 2/10 of an inch deep in there. Now I'm going to go ahead and say, let's just do the whole thing. And let's select a 90-degree bit because we want it to be a little wide so that it does its purpose in this. And let me explain what I mean. If it's a little wide, then we'll get a sharp point down in there. So then we can lower our V bit into this hole and recover the A reference point that will be relative to the old one and therefore good, okay? So we make that mark here, and we make the same mark there, and so now if it does accidentally tear loose, let's say up here, then we can recover it, okay? So if we were doing a lot and cutting them out in squares. Now, the other thing that you can do is just make a real tiny mark in an area, like let's say right there, okay? Now, this is an area that's going to be carved out when it's done, and by that time, we've pretty much got what we want done, which is all of the internals. So, but if this tore out in the process, we could still reestablish the center part of the material. Now, it's usually better to do 2 of these so that you get a 2 different angles to establish a more accurate datum for you. Okay? So the whole point of what I was just talking about is that this allows you, or it will help you in the event that you make a mistake or the material cuts itself loose and you need to reestablish a point so that you can continue cutting without losing the material. Okay, so that's technique number 1. Technique number 2 has to do with order of cutting. Okay, so now if you'll notice, typically speaking with spire, the cuts will come the V cut and then the pocket. V cut and then the pocket and the cutout. Okay? Now, there are a couple of reasons to want to reorder these whenever you finally get ready to do your cutting. So let me give you an example here. I'm going to move this up, and then so now we have V carving and pocket cutting. Okay, and then finally our cutout profile. So when we go to save this, you can see that we can't save all the visible toolpaths. All right, that's fine. We knew that. So we come over here, and now we say, whoops, we've got the pockets, and we really want the V carving to be done first. Sorry, that's my cat chatting to me. The real reason we want this is that when we cut that angle, when the pocket cut comes along behind it, it's going to remove any potential tear out. So what we can do here is select that. You see that we've got arrows to move that up. So I'm going to move the V buffalo part up, and then I'm going to move the V text up. So now, if I select these 2, I can save them. Save them to a toolpath here, and I'm just going to save it to my desktop. Notice that it gave it the first cut's name, so I'm just going to rename this V cut. Okay. So there's our first part. That's going to create a file by itself. So now I'm going to select the pockets. Okay, and I'm going to save that toolpath. You can see that I can save it because it's a 1/4 inch end mill. So let's just call this pocket. Okay. And then finally, what we're going to use is the cutout. Okay. We save the toolpath there. Okay. So we're halfway there. All right. So now whenever we go to the machine, the order that we want to cut is first to do the V cuts. Okay. The reason behind that is that we want to get a clean cut from the machine. All right. So those V grooves will give us a little bit of an angle. Let me give you an example here by drawing a line or a V. Okay. So now let's say that this side is the text and this side is the pocket. Well, once you've cut this part, which is the text, a straight end mill coming down like this, and let me move that over just a little bit so we're perfectly accurate, will only touch that part. So now it's not going to tear out the text at all. None of the text will be torn out. But and the best part of this is now any tear out will be removed by the end mill. So that's the good thing about this. But that's only going to work for us if we sent these cuts in the right order. So we've saved them out. We're going to do all of our V carving first, then we're going to do our pocket, then we're going to do our cutout. But because we're saving these as different files, the Rich Auto Controller is loaded through a USB drive. We need to make sure that for our first cut, we select the V cut file. For our second cut, we select the pocket files. And then for the final cut, we select the cutout. And in that way, any potential break loose of the material will happen on the last file, and that's the easiest file to fix if it's going to happen. Now, I would recommend most of the time that you use tabs. Now, there are some times when tabs are not strictly necessary. Some people may argue with me about this, and so I won't put up a holy war about it. But what I will say is certain cases where you might not need to have tabs is if you've got a very strong double-sided duct tape like I use, and it is so strong that it makes it difficult for me to even get my fingernails underneath it. So if I covered the entire backside of the panel with that, then I wouldn't be too concerned about accidentally cutting out the whole plaque, because the plaque is attached itself. Okay? So what's the other case? Well, the other case is if I have a vacuum table. Now, I have a vacuum table on my CNC, and so if I've got a vacuum table, it is in effect acting the same way as the tape does. And so because that's the case, then I'm okay, golden on that. So what's the final option? Well, actually, the final option as it relates to not worrying about the cutout actually happening. If we draw an extra line out here, okay, let's say this is where I'm going to do my final round over, okay? So I leave a little bit of space, and then I put a clamp here, okay? Clamp here, clamp here, clamp here, only over the pink spot, okay, the pink line. Then everything else is being held by the clamps, and or screws if you prefer. You could put screws in here, and you'll be safe without it coming loose. Now, if you don't do that, then of course the last option is to use tabs. Now, be careful when you use your tabs, because tabs can be problematic in the way they're used. If you create a tab that's quite a length long and very thick, then you may find that you wind up damaging your material when cutting the tab loose. Okay. Now, that shouldn't happen, but it does happen. It's just been a fact in my experience. So if we go over here and we've selected, oops, I picked the wrong. Let's go to the cutout. Here, you want to make sure that you add tabs to the toolpath. Now you can see that this is held over the values from millimeter settings, which my CNC uses. So I would need to adjust this to inches. So let's say that I'm just going to create a 1/4 inch long tab, and I'm going to make it about a little bit thicker than 1/8 of an inch. Let's call it 1.3. Okay. Now I'm going to turn this into a 3D tab. So what's a 3D tab? Well, a normal tab is going to look something like this. Okay. Oops. Nope, not like that. Node editing here always comes in handy. You're going to be a pain in the butt today. There we go. Okay. Well, let's just consider this a square, all right, since my mouse isn't going to cooperate with me, or my shaking hand, I'm not sure which. This is what a normal tab would look like. It would be attached like here. And so then this tab would extend this way. And so it's a little stronger, but it's also prone to a little more damage when you remove it. So what's the distinction? Well, when we look at a V tab, we're basically looking at an inverted triangle. Okay? So a V tab looks like that. Okay? So what happens is, as the router bit comes through and leaves the tab, it climbs up just like it would do if it were doing a V-carve, and then descends down. What this does is gives you an easier area to start your cut. It also is, and basically the net result of this, without going into any more complicated explanation than that, is that you have a tab that's easier to cut out and less prone to damage of the main material. Okay? So if we do that now, we add our tabs. Keep in mind that just by clicking on Add Tabs does not add tabs. This is a strange behavior in Aspire. So you want to go into Edit Tabs. So let's select our cutout profile, Edit Tabs, and then we've got to select the number. Okay, so I'm just going to say 4 tabs, and I say Add Tabs. Now I've actually added tabs. So I can click on Close, and you'll see my tabs are still there. Okay, so the Add Tabs to Toolpath is good. Okay, now we can go in and edit tabs, which is just going to take us back to the main view for that, and we can move our tabs around. So if we had a rather odd shape, let's say, than rather a circle or a square, then we can add more tabs here and there where we feel might be more prone to breaking. Okay, so let's delete all tabs because I don't want that on this, and I'm going to go ahead and resave my file so I don't lose the work that I've done. So what have we talked about now? Well, what we've talked about is reordering the files so that we get the maximum benefit, not doing switch resets or setups for changes of bits. We've talked about the ordering of those cuts so that we reduce cutout and we're less likely to have the material break loose on us. And the last part of that breaking loose is talking about how we add tabs, how we edit, set the tabs and edit the tabs and that sort of thing. Okay? So we can close this out. Now let's take a look and see what everything looks like, because in the same way that some people feel that whenever you're getting ready to do your cut, you should always check this, and I would agree with that. Make sure that you've got your thickness set properly, that you've got your XY datum set properly, your Z0, you know where that's at. All of these things are set satisfactorily. Okay. Okay, so I knew that already. So now we also want to do a review of what the material cut is going to look like. And that is because there's a very powerful tool that we can use in here to step through the cutting process. So let's say that we select all this. These red lines are movements of our tool around in the cut. Okay? So whenever it's not on the surface cutting, this is going to be someplace where the router bit or where the spindle picks up the router bit and moves it to a different point. So let's say that we come over here and we can do a single step. I don't care about that. What I do care about is run to the next retract. What does that mean? Well, it means that if the CNC is over here cutting the pocket and it cuts the entire pocket before it retracts the router bit to go to another spot, then this will allow us to view that. So let's see what the first cut to retract looks like. Okay, well, it was the cutout. Okay, and so as such, it ran the whole cutout. Okay, you can see I still left the tabs off. Now, when we're doing this here in the software, it doesn't matter because we don't have to worry about material being damaged. But it is a nice reminder to us that we need to make sure that we set the order of the cuts so that we don't accidentally make something so fragile that we can't actually perform cutting on it. So now let's go to the next one. Let's go to V Buffalo up here. Okay, so we've got an idea of what it's going to look like. So let's run to retract, and I've got to select the text on this also. Another oddity of Vectric Aspire. So we run that, and that's what we get right there. Oops, I'm sorry, the simulate toolpath is still running. So let's turn the speed up a little bit here. Okay. So there we go. That was our first retract. There's our second retract. There's the third retract. It's created that little pocket right there. Fourth retract, fifth retract, sixth, seventh, eighth. Okay. Ninth. Okay, we're still waiting here. And let's speed this up a little bit. we're just going along on little steps here. If you look down here at Simulate Toolpath, you can see that it's just a little bit of movement and there's a lot of retracts. Now, it's important to understand that those retracts are taking time. When the bit is not in the material, it's not making chips, as my old boss used to say. And you want to be making chips. So there are things you can do, we'll talk about in a later video, that may reduce the number of retracts that you actually have whenever you're doing your cutting. Okay? So let's go ahead and click on step, and we'll just keep stepping through. And I'm just going to go ahead and run it all the way to the end. So let's say preview visible toolpath, and there it is. All right. Now, I'm sorry it's going a little slow here. My computer's a little gutless. No, I don't want to tell you or insult the company that made it, but their initials are HP. This is supposed to be a very powerful computer with a lot of memory on it, and it is not. Okay, so we're kind of stuck here slow for a little while. So I'm going to go ahead and stop the video for just a second, and I'll come back after I get this completed. Well, I apologize. Courtesy of Windows and my HP laptop, the video kind of crashed on me. I was able to save the previous one. So we'll just have to do a little editing, I guess, creative editing. Okay. So where were we at? Well, we were talking about the order of the cuts, and we talked about the retracts. Okay. And so let's see, what else can we do here to help ourselves out? Okay. Well, if we select all these, okay. I said I wasn't going to cover this till the next video, but I'm going to go ahead and cover it now because I think it's useful. Okay. When you select cut order, okay, you can come in here, and this is the order that you're going to tell the machine which and how to cut. Now you will see that I have no options set, so it's just going to go for the default option, and that's typically the shortest path. Okay, shortest path is sometimes referred to as the traveling salesman algorithm if you're a software developer, and I don't mean to bore you with it, but helping to understanding it a little bit helps. The shortest path algorithm says I am going to travel the route that allows me to go the least number or the least distance in all my cutting. Okay. Now you might think, well, that's always the best way to go. Not necessarily. The reason being is that if you cut in certain order, let me give you an example. I'm cutting out of a piece of plywood, and the plywood I know is going to be flexible after a certain amount of cuts occur. Okay, that's just the nature of the beast. As we're cutting material out, the strength and rigidity of the material is reducing. So, you know, changing the way we set our cuts, the order that they go, which kind of cut we prefer first, can affect, you know, once again, the stability of our cut. So you know, this might be considered immediate, intermediate, or a little bit advanced, but everybody has experienced this whenever they're cutting material. It gets a little weaker as you get closer and closer, more material's been removed. Sometimes just cutting these pockets can make things very flexible, especially depending upon how deep the pockets you cut are. And really that's sort of the core of today's video, is how do you get through your cuts without accidentally damaging it. So you can select several of these, and the software is going to pick the optimal solution there. Okay, now you can also tell it where you want it to start. Okay, you can optimize start points, move start points to be closest to selected point on vector bounding box. So, you know, I mean, here, there, wherever the you know, the box is that vector is cutting, You know, this what this is all about, okay? And I'm going to go back and I'm going to say keep current starting points because that's where it was set before and I don't want to lose that, okay? Let's go ahead and close that. So we're at that point now where everything that we'd have to do from here is on the machine. So I'm not going to go out and make a video real quickly, but I am going to say that once you get to the machine, it's really fairly simple and basic. It's going to be based upon the order of cutting that you've implemented here, okay? You see, whenever you save these cuts, as we did before, then what happens is that they're going to go out in the order of selection or order of placement here. So if I say I select I want to do V Buffalo and V text, V Buffalo is going to be done first, V text is going to be done second. Now if I have any questions about that, I can come over here and go to the I think it's the time summary of all toolpaths. Okay, so I can put notes in here myself. Start here. Okay, apply, close. Now, what this will then do is when I create a job sheet, okay, save, and come over here to, oops, sorry about that. If I go look at that summary, it's going to tell me everything that the software has generated and add my notes into it. Okay. So let's go ahead and I'm going to stop the video here and we'll take a quick look at the G code and see if we can make any sense of that and see how we can help ourselves there too. That will really depend, well, I'll get to that in a second. In woodworking, there's an old adage. That is that you want to measure twice and cut once. Once you've cut, you're committed to that. Okay. Now, because you're adding software into the mix, I strongly recommend that you create a checklist for yourself so that you go through all the switches that can be set in the model that you create in whatever software program it be, whether it's Bobcat, Aspire, HSM Works, you name it, okay? Because the problem is there are preferences, dialogues, and the pop-ups that occur and all this. I'm a software developer for a living, I know, okay? And there's no point where you can say, oh, this is all the list of all the things that can happen. So I recommend that you get yourself a checklist and or create one and make sure that you check the thickness of the wood. Did I set that properly? Check the millimeters versus inches. Did I set millimeters when I meant inches or vice versa? Do I have a large clearance bit for my V carving? Or did I accidentally set the V bit to be the same when I didn't intend it to? These are all considerations that you have to go through whenever you set up your cut G code to run. So I just found out I made a mistake in there. Fortunately, I caught it before I came out here, and it's going to save me a lot of time. Okay, so keep that in mind, and Godspeed, good fellas. So let's cover a little bit that I didn't talk about in the video earlier regarding the way you set up and what some of your options are in the way of running files and stuff. Now, on my 1325, the memory storage capacity is 500 megabytes, and given that G code files are text, that'll go a long ways. Text files don't take a lot of space. But let's say that for some reason, one way or the other, you want to run it off of your USB. Well, you can do that, okay? And the way you do, basically, all of your files will be loaded through the USB port anyway, so that's not an issue. But when you insert your USB key, okay, you then have the option, okay, if you go to menu, press menu, and unfortunately you can't see this because there's too much in the way of refresh rate between the 40 kilohertz or 40 hertz camera and the 60 hertz here. But on the menu, if you go down here and you go to operate file, okay, you can copy files, delete files, view files, pro info, all this. Well, if you go to copy file, that's where you go to the USB drive. It says udisk file. But let's say that, okay, now I've got 5 gigabytes of text here that I want to run. Well, you can run it directly off the USB also. So let's say that I clicked on run, okay? Right there, the very first option is to select udisk file. And so you can go straight into your USB, and if you've got a really huge file, then that's very possible to do, okay? So that makes it handy. But the one last thing is whenever you copy a file into the computer, it's there forever. So if you're very happy with that file, you don't have to delete it. You can come out and reuse it. So if you've got a part that is going to be a common part for you, maybe it's a mass production part, it's here all the time. Okay, so you can just come out, select it, and say go again. All right, and that's very handy. It's very handy. I've had other CNCs that didn't have that functionality. Okay, so next let's talk about your setup. Okay, so whenever you go to, there's a home button right here. Okay, that will move the machine right to this position right here. Okay. This is the 0 position for the machine. I consider this the operator portion of the machine. First of all, the cable is, you can get an extended cable, but this is fine for me. It works just fine. And what it will do is move the gantry to right here. So I'm going to go ahead and press home. Okay, and it gives you the option. Do you want to home all? Do you just want to home X? Do you just want to home Y? Etc. You're pretty much better off to just home all. So I press the OK button here, and it's going to move forward to me, and I'm going to move my bottle of water out so it doesn't get knocked over. Okay, so now it's home. Okay, so let's say that I want to establish my XY coordinate. Well, I have X, Y, and Z. X, Y, and Z. Z up, Z down, Z up. Y down, Y up. X negative, X positive. I meant negative and positive for everything. Okay? So you may see me do this. Now, you don't have to do it this way. There's a lot of different ways to do it. I'm just most comfortable doing this way. So what I typically do is run it down until it's almost at about the Z height of the surface of the table. Okay? And that's so that I can get the XY directly from this corner right here. Okay? So if I move that X over and the Y back, you can just press it in step. And I'm going to move it down to Z. And then, I just very gently, one step at a time. It's only about 0.5 millimeters. I set that. So I move it over here. And now I'm pretty comfortable with that as my XY datum. Okay? So there's two different buttons here to establish your datum. One is for XY and one is for Z. So I go ahead and press the XY button. You can see the numbers have zeroed out here. Now I want to establish the datum for Z. Well, what I'm going to use is this little brass plate here. And if I can get it out, give me just 1 second. What happens with this plate is there's a connection electrically that goes through the end of your metal bit into here. So there's a zero Z-axis combination of buttons. You press these left two buttons right here. So let's move Z up just a little bit. Now we need to be on top of the table, so I'm going to move the X-axis over and the Y-axis up. Okay. Now what I do is place the pad right here. As soon as your bit touches it, the circuit is closed and it will pop up. So I'm going to press the on-off button first and then the menu button. Release it. You can hear it moves very, very slowly. That speed is adjustable inside of your controller. As soon as it touches it, it's going to retract. Now you absolutely want to make sure that you pull the brass sensor out. Otherwise you're going to get a flying object moving extremely fast and you could get hit by it. Okay? So we put it back up here and we do our cut. Okay? So we do whatever we do with that bit, and whenever it's done, the machine will retract right back here to the XY position with the Z-axis fully retracted. Okay? So when that happens, you simply, there's a ER20 collet right here, which you'll unscrew. You can pull your bit out and put the new bit in. Now, because we've already established our XY coordinate, the only thing we have to do is, because we put the new bit in, we almost certainly do not have the same Z-axis, or Z height is a better word to use for it. So we'll put that back down there, and we'll move our spindle down, and then we're going to press on-off again. And so if this were a V-bit or something like that, then it would move down. It's going to establish the new Z height, and we're golden. So this makes it very easy for you to do the same cut over and over and over again. Okay? So you can see it just closed out. You pull that back out, and we are good. So what's going to happen is that every time you make a cut, you're going to have to swap out a bit if it's a different bit. And so in the process of swapping those bits out, it's very simple. Okay? So let me see if there's anything else I wanted to talk about here. We've talked about the USB stick. This is how you load things through the USB port into the cable, into the computer. We've talked about the fact that you can run a huge file out of the USB disk. We've talked about you can leave files permanently on the controller, okay, if you're happy with them. We've talked about establishing our XY coordinates and our Z coordinates and how the buttons differ, and how once we set the XY datum, if we are using the very same piece of material, then we're good for that for the rest of the cutting. And we've talked about using the CAD sensor, okay, to establish your Z height, okay. Now I recommend the CAD sensor. It's going to give it to you exactly what you know. So you can't get it more accurate than using the CAD sensor. So I strongly recommend using that. And then finally, you want to always make sure that you pull the CAD sensor back up and wrap it around the top of the spindle. Okay, there's no danger of the brass sensor causing any kind of circuit short or anything like that. That's not going to happen. Okay? Now I wish that I could say, are there any questions, but because I'm talking to a camera, I can't do that. So in any event, if you've got any questions, please feel free to ask on the YouTube page, and I'll try and get back to you as soon as possible. Until then, take care. I just wanted to reiterate something here that you're going to see as we run through the video. And that is, again, as I'm getting down on my knee, I'm swapping out router bits. And it's just an indicator of how easy it is to do. It doesn't take any time. And keep in mind that it will help you to keep your XY datum. So you need to do that throughout the cut. And from there, that's it. Enjoy the video. Enjoy Led Zeppelin's karaoke.